In Python lists, we have a bunch of elements kind of strung together, almost like they're in a series of bins. And so in order to be able to use these series of bins, this list, we want to be able to put things into them and also be able to take them out. And so taking individual things or accessing individual things is what we mean when we say indexing. So if we have a list that looks like this that we create in Python, and we say some list like 1, 3, 7, 9, 10, a Python list has indexes for all those or locations. Sometimes we might even think of these as addresses, and we often call them their indexes. So Python lists always start with an index of 0, and they count up so that we can access any individual element. So if we were saying, oh, something like, I want to know what this from a list at location 3, we mean we're talking about the 9, the thing at that location. So we can change what's in the list. Lists are what's called mutable. And mutable is just kind of a fancy word for meaning that we can change it. So I don't mean we can reassign a new variable name. That's easy. We can just make, these same values in another variable, but actually changing what this list is what's called mutable. So sometimes we change the elements. Often in the beginning, we're just adding and taking them out. But we want to be able to index them individually. So we're always referring to their index, and we use this nice square bracket notation. Python has this extra feature that's unlike a lot of programming languages in that it also has this idea of negative indexes or negative indices. So that means instead of just being able to say 0, 1, 2, 3, 4 as locations and so on if it was a bigger list, we also have this idea of counting backwards from the back of the list. So this would be the -1 index, the element at -2, -3, -4, and -5. So the item 9, we could refer to it both at a list at 3 and a list at -2. So basically, these two things are equivalent. So a list at 3 is the same as or equivalent as a list at -2. Now, this is a really useful thing because a lot of times we want to, get things that are the last of the list or the second last item, and we don't have to worry about referring to the length of the list. Now we can. So, for example, lots of times if we don't know that we have negative indices, and we want to refer to something like the end item of a list, we may say something like this. So, a list, and the length of this is 1, 2, 3, 4, 5. So I might say, well, I want to get the element of length of a list, and then I'm going to say -1 because length of a list is 5, -1 gives us the fourth. The reason it's always -1 for the last item is because we always start with our index starting at 0, and that's pretty standard across all of computer science that we would start counting at 0. And we'll learn more about why that's the case going forward. But for now, it's just important to see that we can have something a little bit easier, that instead of something like this, we could just say, well, that's a list at -1 gives us the last element. And that doesn't matter if the list has 1,000,000 items or 5 items or 20 items. Saying -1 means the last thing. So we have regular positive indexes we can use and negative indexes we can use. The next thing we're going to talk about is how to do slicing. So slicing uses similar notation, but it's different in a lot of ways. So slicing is when we want to take potentially a chunk of a list. So we can think of different ways. So we can think of a list. I'm just going to draw it as a rectangle. So a slicing of the list might be like, okay, I just want to take off this chunk, and I just want to deal with, the elements that are in here. Or I just want this middle chunk and take a slice like that of a group of things. So maybe some middle section, maybe some section at the end of 5 items I want. Slicing can also look like this, where we have a list of items, and I want to take something more like, think of it like a loaf of bread slice, where I want to keep taking a chunk of something. So I'm going to take this item, then this item, then this item, then this item, where maybe that's every other item or every third item or something like that. And we're able to use those slices to get different chunks of values. So let's look at an example. If we have a list, so we created some sort of Python list that looked like this. And for now, I'm just going to use the numbers so we can be like in order, so it's not too complicated, but 1, 2, 3, something nice and sequential. And so this is, I'm going to write the indices just so we can talk about them pretty quickly going forward. So I'm just writing the indexes below. And this is something I would do even if I was, working on a program and or some sort of problem and I was using slicing. It's not overly complicated, but it's easy to make a kind of a simple mistake because you miscount or something kind of simple because you didn't take the time to maybe just draw it out on pencil or paper just to kind of get your head around the indices that you're talking about. So sliced sets up like this, where we have this idea of this list, and let's look at something where we first want to take a chunk of something. So the notation for taking a slice when we're talking about taking a consecutive chunk looks like this: the start index and the end index. So if I want to take, I want to create a list that looks like this, where I'm going from, let's say I want to get 3, 4, and 5. What that would look like for my Python notation would be, that would be the slice of the list from a list, square bracket. And so the index of the 3 is 2. And I use colons here. So I use the start index. Sorry, this should be a colon here. I use the start index and then the end index. So I want 3, 4, 5. So the end index is 4. But the way slices work is you give the index of the thing you're counting up to, but not including. So in this case, I would use 5 because that's the index of the last thing that I'm counting up to, because I'm only really going up to this chunk here. So I don't want to include it. And so that would give me this sublist. So slice is a list. So if I was to print this, it would print it like a list. If I was to make a new variable, it would now contain a list, not just the items in some kind of unstructured way or not a string of them. It would actually give me the things in an item. So let's suppose I had a line in a Python program that looked like this. So maybe I call it slice1 equals a list, and I said 1, and I was to figure out what that was. Well, that item or that chunk would be now equal to having the item from the first location 1 index, so that's the 2. So it's going to include up to, but not including the element at location 6. So it counts all the way up to location, but not including location 6. So in this case, it's the number 6. So 2 through 6. Sorry, 2, those numbers up to it. So it'd have 2, 3, 4, 5, and 6. So again, the item 6, which isn't getting up to index 6. And that's how we do a slice that's sequential. We can also use negative indices in this as well. So let's look at another list. So I want to have some sort of so we'll look at something with maybe something more unordered. You can see I got duplicate elements, and it's not a big deal. 2 4s, I got 2 8s. We can also use our negative indices as well. So we can say something like, slice 2 is equal to list 2, and I'm going to use a slice where I use we'll go still going frontwards. So we'll say going from element 0 up to -1. And what would that be equal to? So that's going to be the start value is this 8, and it goes up to but not including this value. So we're going to stop before that -1th value. So that gives us a list. Again, it's not that something else. It's another list that's now in this case smaller. And it goes up to but not including the last element. So essentially we've sliced off the last element. So we use this a lot in text where we want to take off maybe an end of line character or maybe even punctuation that's not part of what we want. So we get this nice sublist like this. Now, one of the things that we can do is, yeah, we can use like negatives and use these in kind of weird ways, but one of the things that becomes really apparent when we start working with lists, especially when we have this idea of negative lists, is, well, what if I want to go backwards? Like, what if I want to start here and go the other way? And there's a couple different options for that. The first is we have to update how we think of our notation. So the slice list notation then is not just start and end, but there can be a third one, which is, I'm going to say an increment. So sometimes we say it's like a count by, and that can also be positive or negative. Positive if we're going this way, right? And negative if we're going to count or move through our list this way. So we can do, first off, we don't see it here because if we don't have the third item, Python just assumes what you're counting by. So the default is it'll know that you're thinking of +1, and if you give it reverse things, it'll know you mean -1. So I'll show you what I mean that you can try putting into REPL as your own test. But if we said something like this, slice 3 is equal to list 2, and this time we gave it something that's clearly like the start is after the other one. So if we said something like start at -2 and go to 1, what would that do? Well, in this case, it's going to start at this -2. This is the element at -1. This is the element at -2. So we're going to start here with that 3. And now Python knows that if I'm going from here as my start, right, and I'm going all the way to the 1 element, which is here, but I'm not going to include it. So really, I'm stopping here. So 4 is going to be my last thing. Python knows, hey, you're going backwards to the list. You've given indexes of start and end that mean we have to go backwards. It knows that you're actually kind of saying there's a -1 count by here. So it'll create a list that looks like this: 3, 1, 8, 7, 4. And so it knows that it's there. So that kind of slice index is the same as saying something like this. We could have said list 2 with slice indexes of -2 to location 1, counting by -1 or moving by -1. These two things are the same. They'll both give you this list because Python has just figured out that it's a default. So let's look at something if we say a different thing other than counting by the defaults of -1. So let's have another list here. Oops. So that's 9. So again, I'm going to write some indexes here. And so sometimes we want to get like every other element, right? Something that isn't the sequential, which is common, but not the only way we can do this. Sorry, this is -1. All the way through as what our negative indexes would look like. So something a little bit more complicated like slice 1 equals a slice from a list that goes, we'll use positive numbers first. So we'll say it starts from 1, goes up to location 5, and counts by 2s. So I say count by, but I really mean move by. And what that does is means we start here. So we're starting at location 1, which is this index here. And we're going up to location 5, which is this one, but we don't want to go, we're not going to use it. So we have to stop before it. So none of our items will be before, or sorry, after that line, because we'll never get past or through to location 5. But now we're counting every other one. So basically what happens is this thing starts at 10, and then it's going to go from this start, it's going to skip and go here, and it's going to try to skip and go to the 7, but because we don't cross that line, it's just those two elements. So when we do that, we get this list that looks like just the 10 and the 3. Right? So just that element, the 7 will not get there because we can't cross that line. We can't use the thing at location 5. And we've got every other one. And if we use that just on a regular list, so it's very common to think of like every other. Every other for that list is a list where you might say from starting at 0, right? And you want to say going up to the end, and you want to say, well, I'm counting by 2s. The question is, what goes here? It's really common to say, like, I want every other item, or I want the even indexes or the odd indexes. The problem is, like, how do you say, I want to include the last item? Because we already said that when we give an index like 5, that's the last nut you count up to, but not including. So what goes here? Because if you say -1, that means our line is like this. We don't cross that. And if you say -2, it's here, and -3 is here, so it's even less. The answer is that we have this idea where our indexing slice notation is to say start at 0 and leave it blank and say count by 2s. And more importantly, if you're using the 0, like that's the start of something, you don't even need that. So this is much more common where we leave that blank. So you end up seeing something like this, : 2. And that means start at the beginning, go to the end, and count by 2s. So doing something like this would create a list that looks like this. The first item is what would happen. So we're counting every other item through our list all the way to the end. And we can do negative counting as well. So we can say, well, what does something like this look like? Slice 2 is going to be a slice from a list where I'm going to say from the -1 location, and I'm going to go all the way but not including, so I don't want to include the first number, let's say, and I'm going to count by -3s. So again, we have a start and an end. So we're starting, our value starts here at the -1 item, and we're going all the way. We can't cross this line because that's kind of, we can't include this thing at 0 because we count up to but not that item. And we're counting by -3. So now I go 1, 2, 3 here, and it would try to go 1, 2 to that one, but it can't cross the line, so it doesn't include that item. Even though it gets 2 the way there, you can't get the third one, so you can't use it. So we're just talking about the item that's here, the first one, which is 12, and then the next thing it could land on, which was at 3, and that's the entire sublist. That's all that we get out of that negative slicing. And there's a lot of different combinations, and sometimes they can be kind of confusing. And that's why I said it's useful to write them down sometimes to make sure we really include the right numbers, or think, especially when we're going backwards and counting by different numbers. And obviously, we don't want to forget that these have those defaults. So one of the most common things we see is in a list that's really quick to do in Python is reversing a list. So reversing a list is to say, well, I want to start, so let's say this variable called reverse would be a list. If I want to reverse that list, I want to count by -1s, right? Because I want to take the last thing. I want to take the last thing and count backwards. So you might think, well, that start is -1, and you can say that, and then you want to go to 0, but you want to include the 0th thing. So what index should go here? again, it's kind of like this example we did before. Well, I'm going to leave it blank because blank would mean we'll just go the other way, like use the beginning. And the even simpler version of this is instead of doing that, we say reverse equals a list. And Python is kind of smart enough to figure out that you just can leave out the beginning and end because we're saying default and just say I'm counting by -1. And then Python says, oh, you want to count by -1s. That means you must be meaning to start at the last element of the list and use this as the last element you want because you're counting by -1s. And Python will do that for reverse. So this is one of the most common things we see where it can kind of look confusing if you don't recognize that leaving it blank uses these default like go to the end fully of the list. So we can leave it blank if we want to just go to the beginning, sorry, go to the end or start from the very beginning or what have you. We use these kind of like empty defaults there.